Hello class, this is Mr. Holmes again. Apologies for the cutoff, but I ran out of data on the iPad, needed to re-record. So continuing where I left off, we're now going to talk about how to rotate a polygon to form a 3D figure. And this does get a little complicated, but we're not going to go into too much detail. I'm going to show you an example from the textbook to show you how this works. And we'll apply it to other ones. Right here. So example 5, rotate a polygon to form a 3D figure. If I rotate an isosceles triangle about the altitude, what 3D figure does the triangle form? So if I cut it through the altitude, basically I'm going to just spin it very fast about the center of that triangle. And if I do, it's going to form a cone. And you can do this with any 3D figure. The three we're going to focus on are circles, triangle, and a rectangle to show what 3D figures. And if I cut it different, it will give me a different shape. But basically, for the most part, it's going to be through the altitude or center of your 2D figure. So we'll go into this now to show how to do this. So, in general, this is what you're going to need to know for this. If I have a 2D object, so for example, if I have a triangle and I rotate it about this line in the triangle, it's going to form a cone. I just showed you that. If I have a rectangle and I rotate it through the middle, this is going to form a cylinder. Because I'm spinning it around really fast, it's going to be a cylinder. And the other one is if I have a circle and I rotate it around really fast, it's going to be a sphere. So those are the general ones. So if I rotate this one about the middle right here, it's going to form a cone. Because it's just going to spin around, it's going to be a cone. What 3D figure is formed by rotating triangle ABC about BC? So I'm going to draw you what this figure looks like. So I have a triangle, A, B, C, and this time I'm rotating it about BC. So if I rotate it other than the center, it's going to form slightly different. So if I rotate it around like this, it's going to basically look something like so. It's going to be two triangles when you reflect it, but really if I rotate it really fast, this middle piece is going to be my circular part, and you can see that I'm going to have a cone on the top part and a cone on the bottom part, and this is going to be a double cone. So if I don't rotate it directly through the center of your figure, and another thing, it's most likely going to be a double of it. Usually a double cone could be other shapes too. So you could have a double cone. So it's basically two cones put together in the middle. And that's really all you need to know about rotating an object. You're just spinning it really fast, and if I form it really fast, it's going to be one of the three shapes. Cone, cylinder, sphere. It has to be circular. It will never be anything non-circular, so I can never form a cube or a type of prism. It cannot do it when I rotate it. It must be circular. The last thing we're going to look at is examples 4 through 9 on here, just to do some quick practice. So 4 through 7 is to complete the table, and we're going to use Euler formulas. Remember, your faces plus your vertices equal your edges plus 2. So in this case, if my faces is 5 and my vertices is 6, 5 plus 6 is 11. I need it to equal e plus 2. So for number 4, 5 plus 6 equals e plus 2. If I solve for e, I'll get 9. Number 5, 8 faces plus my vertices equals my edges plus 2. So 8 plus what equals 20? That will give me 12. Number 6, faces plus 12 equals my edges plus 2. So what plus 12 equals 46? That gives me 34. And then number 7, faces plus vertices equals my edges plus 2. So 66 equals what plus 2? That'd have to be 64. Again, quick math to do. Just set up your equation, solve for your missing part. Number 8, what polygon is formed by the intersection of plane N and the octagonal prism below? Just the outline and figure right here. Since I'm cutting it parallel to the base, it's going to be the shape of the base. In this case, my base is an octagon. So that's what my cross-section will be. If I cut it perpendicular to the base, it's going to be a rectangle. And number 9, describe the 3D figure that is formed by rotating the isosceles right triangle about the hypotenuse. So the hypotenuse is the longest side. That's my right angle. So if I did draw it, basically if I rotate it really fast, it's going to look something like the one we did before. And then this is my circular piece. This is going to be a double cone because I'm not rotating it directly through the altitude or the cutting it in half your figure. So when I rotate it about something other than the center, it's usually going to be a double of it. In this case, double cone. So this concludes the video. Again, you learn Euler's formula, how to calculate cross sections of polyhedrons, and describe rotations of polygons about an axis. Sorry for the cutoff on the video, but again, these examples will help you solve the questions later on. This is Mr. Holmes signing off. Have a great rest of the day. Take care.